All right, this is an RCV 300M in a JLJT front 44, and we've got the shaft completely in without the boot, and we have nice movement here on the hub, and the ring and pinion is not turning, so it's just turning the spider gears inside the differential. As you can see, we have a slight gap right here. And if we tighten this up, we can now no longer turn the shaft. So what I'll do here is I can turn it with a pry bar and force it to turn, but you can tell something is definitely not happy. And again, what I'll do is I'll loosen this hub bolt just like maybe a half turn. And now we can freely move this by hand. All right, now we have the original shaft resting on what would be the back side of the hub bearing. And we have the press mocked up here to where everything is sitting on the pins. And we've got a small gap here between the top of our press, or the bottom side of our press, and the shaft. And then measuring this gap is just a little over, it's probably about a little over 1/8 of an inch, we'll say 3/16 of an inch. And then we will grab the RCV shaft and measure this gap, and it is now approximately 5/16 to 3/8 of an inch. So RCV advised us to grind down the tip of this because they felt like when we tightened it up, it was pushing against the center pin of the differential. So we know now that the shaft is not too long, and we've cut just enough to where we feel comfortable with that being not too short. So I did notice something while we were doing this video. You can see a nice little shiny line around the surface of the seal, or where the seal would ride here, and there's a shiny little surface right there. So what I've done is I've looked down through the axle tube, and I found that this may be actually bottoming out on the journal of the side of the carrier. So what I'm going to do is take a little bit of this off, enough to where we still have a nice smooth surface ramping up to where the seal slides in. So I believe that's our issue, is whenever we tighten this in, I believe this seal surface here is too far this way on the shaft compared to the stock shaft. So what I'm going to do here is, now that we know we have the shaft in here at the same height, we're going to go down here and look at this, and our seal surface starts at 4 1/4 and goes to 5 1/4. So 4 1/4 from this surface to where this flat starts. All right, so stock shaft is also 4 1/4 to 5 1/4. So what I think I'm gonna do is, it looks like there's a definite machining difference here where this ramps up to the seal surface on the RCV versus this shaft. So I'm gonna measure the diameter of the shaft as close as I can to this seal surface. All right, so we're gonna go down here right to maybe 1/4 inch above that seal surface, and the smaller diameter is 1.321. And we will go down to that same spot just above the seal surface, and we have a diameter of 1.372. So definitely several thousandths difference there. So what I think we will do is come in here and grind down the shaft just where that little line is, and then have a nice little ramp up to this. I'm actually going to see if I've got a friend that does machine work. I'm going to see if he can put this in his lathe and machine that down just so it would look nicer and be better. I took this over to a friend of mine, Randy, over at Specialty Machine, and he chucked it up in the lathe and he took some material off past where that interference was. So we've got the bell of the CV back on, and we're going to throw this in and see if it works. So hub bolts are tight, boot is on, 36mm is torqued in, speed sensor's on. We don't have a gap between the hub and the knuckle. It is completely tight, and check this out, like butter. So thank you, Randy, over at Specialty Machine. You are a lifesaver.